Hi students, this is Sivakumar, 11th standard mathematics. Now we can start with chapter number 1. Sets, relations and functions. Sets, relations and functions. Now, a brief introduction about that. Sets, particularly the concept of sets, might have learnt in 10th standard itself. Those who have studied 10th standard in state board, particularly those who have studied in CBSE stream up to 10th standard, might not be knowing the concept of sets. Anyway, I'll teach you the basic concepts of sets. Listen carefully. A set is a collection of well-defined objects. Set is a collection of well-defined objects. For example, the set can be represented by any one of the English alphabets of capital letters. I consider capital A equals the set of natural numbers. This is a representation of set in a descriptive form. The same set can be represented in set builder form. A that is equal to set of all x such that x belongs to capital N. You know very well, capital N represents set of all natural numbers. The same set can be represented in another way. You know that natural number starting number is 1, then 2, 3, 4, 5. It is going on. So 3 ways you can represent. This is called the roster form of a set, then set builder form of a set, a descriptive form of a set. For your reference, I write over here descriptive form, set builder form, and roster form. Now, I consider two sets. Let A that is equal to 1, 2, 3 and set B that is equal to 2, 3, 4, 6. Now I am going to find out the union of two sets. What symbol it is? Union. A union B means you have to write all the elements of A and B. At the same time, elements cannot be repeated in a set. So we can write them in order. 1, here 2, here also 2. You have to write only 1, 2. Already told you elements cannot be repeated in a set. Here 3, here also 3. Write 1, 3, then 4, then 6. That is A union B. Now I write A intersection B. What symbol it is? Intersection. Intersection means you have to write the common elements of A and B. That is the meaning of intersection. In the sets A and B, what are the common elements? We have 2 and 3. So 2 and 3 are the common elements. Now, you can go for a set difference A minus B. Sometimes instead of minus, it may be given slash. The slash represents set difference. Set A minus set B, that is equal to, write that set A first, 1, 2, 3, minus set B, that is 2, 3, 4, 6. In A minus B, you have to strike out the common elements first. Common elements, what are they? 2 and 3. After striking out the common elements, the elements left out in the first set, that is A minus B. So which one is left out? 1. You are not supposed to consider 4 and 6. So 1 is the answer. Like that, even I can find out B minus A. B minus A, first you have to write that set B, 2, 3, 4, 6. Then set A, that is 1, 2, 3. Here also you have to strike out the common elements because you have that symbol minus. Minus represents set difference. Here the common elements are 2 as well as 3. After cancelling the common elements, the left out elements in the first set, what are they? 4 and 6. That is the answer. You are not supposed to consider that one here. Okay. This is A minus B. This one is B minus A. Then, if a set has countable number of elements, we can say that is a finite set. Finite set. Here we have only 5 elements. It is an example of finite set. It is an example of finite set. It is also an example of finite set because countable number of elements we have. Correct? Here set A has only 3 elements. Set B has only 4 elements. Set A union B has only 5 elements. These are the examples of finite set. But look at that A. Here, set of all natural numbers have taken 1, 2, 3, 4, 5. It is going on, no end at all. This is an example for infinite set. Uncountable number of elements are there. Now, I have to tell about that empty set. For example, I consider A that is equal to 1, 2. A that is equal to 1, 2. And B that is equal to 5, 6. You are asked to find out A intersection B. A intersection B, already told you, whenever the intersection comes, you have to write the common elements of the sets A and B. Here we have 2 elements 1 and 2. Here we have 2 elements 5 and 6. But nothing is common. In that case, you have to mention. It's an example of an empty set. Empty set can also be represented in other way. These are empty sets only. Now, proper and improper subsets. Proper and improper subsets. I consider the set 1, set A, that is 1, 2. Now I write the subsets of A. Subsets of A are empty set is a subset of A and 1 is a subset of A and 2 alone is a subset of A and 1, 2 also the subset of the set A. See, for getting the subsets, there is a formula. Number of subsets that is equal to 2 power n. That's a formula. That is equal to 2 power N represents number of elements in the set A. How many elements are there? How many elements are there? 2 elements. Write 2 over here. 2 2s are 4. So you can count now 1, 2, 3, 4. So it is it's an empty set. Empty set is a subset of the set 1, comma 2. Even a single elements, what are they? 1 as well as 2 are the subsets of 1 and 2, 1, comma 2. And the same set 1, comma 2 is a subset of 1, comma 2. So 4 subsets. Out of 4 subsets, these two are 1 and 2. 1 and 2 are the proper subsets. Proper subsets mean here the set has only one element. That element must be in the set A. At the same time, at least one extra element must be there in the set A. Which one is the extra element here? 2. Therefore, 1 is the proper subset of A. Like that, I consider 2. 2, the same 2 is here. At the same time, one extra element is there in A. Therefore, 2 is also the proper subset of A. Then, empty set, there is an empty set, correct? And the set 1, comma 2 are the improper subsets. Empty set is an improper subset. At the same time, here 1 and 2, here also 1 and 2, same set. These are the improper subsets. Okay, empty set, the same time 1, comma 2, the same 1, comma 2 in set A. So these are the improper subsets. Next, you know about the natural numbers. Natural numbers, set of all natural numbers 1, 2, 3, 4, 5, etc. It is represented by n. Then a set of all whole numbers is represented by the letter W. 0, 1, 2, it is going on, 3, it is going on. Uncountable numbers are there. Now a set of all integers, it is represented by the letter Z. So all the negative numbers, minus 3, minus 2, minus 1, minus 2, minus 3, minus 4, etc. 0, 1, 2, 3, etc. Now, set of all rational numbers is represented by the letter Q, capital Q, of the form P by Q. Condition: Q is not equal to 0. Q is in denominator. If it is 0, anything by 0, that is infinity, undefined. Therefore, the condition Q is not equal to 0. Next one. Q dash represents set of all irrational numbers. Irrational numbers. Irrational numbers have learnt in that lower classes and all. That means it's a non-terminating and a non-recurring decimal expansion is called irrational number. At the same time, number in the form of a radical sign. Radical sign, you know that? Radical. This is a radical sign. That is also irrational numbers. For example, root 2, root 3 and all irrational numbers. So this one is a rational. Rational complement is irrational. So that I have mentioned Q dash. Next one is R. R represents set of all real numbers. Set of all real numbers. So real numbers, that capital R is a superset of all the number systems. W, whole numbers. Whole number is the natural numbers are subset of whole numbers because all the natural numbers in whole numbers. Natural number is a subset of whole numbers because all the natural numbers in whole numbers. Natural numbers and whole numbers are the subsets of set of all integers because natural numbers here even whole numbers in Z. So we can say natural numbers and whole numbers are the subsets of Z. At the same time, Q, that is a set of all rational numbers. N, W, Z and all subsets of Q. Why, sir? Sir, I consider 3. 3 can be written in this form because 3 that is equal to 3 by 1. Even you can take minus 2. I take minus 2. Minus 2 can be written in this form minus 2 by 1. So anything in the form of P by Q is a rational number. Irrational numbers Q dash. Capital R is the combination of all the numbers. It has natural numbers, it has whole numbers, it has set of all integers, it has a set of all real rational numbers, and it has even set of all irrational numbers. Okay. Now, symmetric difference. Symmetric difference it is represented by the symbol delta. I consider A delta B. Formula A minus B union B minus A. A minus B union B minus A. One more way you can represent A delta B. A delta B that is equal to A union B minus A intersection B. So two ways you can represent the symmetric difference. This symbol is a set difference. This symbol is a symmetric difference. Okay. Now, cardinality of a set. Cardinality of a set. I considered a set A that is equal to 1, 5, 7, 0.3, 1 by 2. Now, cardinality of A is represented by n of A, that is number of elements in the set A. Just you have to count and write 1, 2, 3, 4 and 5. How many elements? 5 elements. Each and every one is called an element. See, 5 is an element of 5, not this 5, particularly this 5. 5 is an element of set A. 5 belongs to the set A. What symbol? Belongs. 5 belongs to the set A. So I consider one number 10. 10 is in the set A? No. You have to write like that. 10 doesn't belong to the set A. Okay. Next, singleton set. Singleton set. A set which has only one element is called a singleton set. A set which has only one element is called a singleton set. I can give an example. A that is equal to the set of even prime numbers. You know very well, out of all the prime numbers, 2 is the only even prime numbers. Other prime numbers and all odd numbers. It is a very good example for a singleton set. A set has only one element. Okay, already told about that empty set. Empty set means a set which doesn't have any element. Empty set can also be represented as can also be called as void set. Another name for empty set is void set. Empty set or void set. Or you can say null set. Example, I take A that is equal to the set of human being with 3 eyes. Is it possible? Anybody is having 3 eyes? No chance at all. So A that is equal to empty set. Now you must be learning some properties of set operations. That is in your textbook. Commutative property, A union B that is equal to B union A, or A intersection B that is equal to B intersection C, B intersection A. For commutative property, we are considering only 2 sets. Now, next one is associative property, A union B union C that is equal to A union B union C, or A intersection B intersection C that is equal to A intersection B intersection C. Look at the left hand side and right hand side. We have 3 sets on in order only ABC, ABC. But look at the brackets. Here brackets for A and B. Here brackets for B and C. Associative property. Now distributive property. A union B intersection C that is equal to A union B intersection A union C. And A intersection B union C that is equal to A intersection B union A intersection C. Now identity. A union empty set is A. A intersection union that is equal to A. So that is not union, universal set. It is an universe. I give an example for that. Identity axiom. Okay. AXIOM axiom. That's a property only. So what is given? First one, A union empty set that is equal to A given, and second one, A intersection universal set. What it is? Universal set that is also A. I give an example. A that is equal to 1 comma 2 I consider. Next, now I'm going to find that first subdivision, A union empty set. A that is 1 comma 2 union empty set. Correct? These were same only, empty set. So union means you have tried all the elements of the 2 sets. We have only 2 elements. What are they? 1 and 2. Write 1 and 2. 1 and 2, here it is. Correct? What it is? A. Now we have proved A union empty set is A only. Now for the second subdivision, You are given universal set, correct? I consider universal set 1, 2, 3, 4, 5. It's an example only. Let and set A equals, I consider only 3 elements 2, 3, 5. Two, 3, 5. Particularly, all the elements of A must be in the universal set. For example, one more example I can give. Set of all students of your class. That is a universal set. I consider set A as set of all girls in our class. All the girls of our class, the students of our class only, no? Like that. Here 2, 3, 5 are the elements. The 2, 3, 5, all the 3 elements must be in the universal set. Now I can find A intersection universal set equals set A equals 2, 3, 5 intersection of universal set. What are the universal set? 1, 2, 3, 4, 5. Now, you know that intersection means you have to write the common elements of the two sets. What are the common elements? 2, 3 and 5. What about 2, 3 and 5? Here it is. That is A. We have proved A intersection universal set. That is also A. Proved. Now, next property is idempotent. A union A that is equal to A. A intersection A that is equal to A. Obviously, I consider set A that is equal to 1, 2. 1, 2 union 1, 2 is 1, 2 only, no? What is 1, 2? That is A. Like that. 1, 2, I consider the same set 1, 2. Here 1, 2, 1, 2, 1, 2. What symbol here? Intersection. Intersection, what are the common elements between 1, 2? Set A and set A, 1, 2 only. What about 1, 2? That is A. Next, absorption. A union A intersection B that is equal to A. Next one, A intersection A union B that is equal to A. That is the property absorption. Next, De Morgan's laws. A union B whole dash equals A dash intersection B dash, and A intersection B whole dash equals A dash union B dash. That dash represents complement. A minus B union C that is equal to A minus B intersection A minus C. A minus B intersection C that is equal to A minus B union A minus C. So totally 4 De Morgan's laws. And on symmetric difference we have 3 properties. A delta B that is equal to B delta A delta B delta C that is equal to A delta B delta C, and A intersection B delta C that is equal to A intersection B delta A intersection C. On empty set and universal set we have 6 properties. Complement of empty set is an universal set. Complement of universal set is an empty set. A union A complement equals universal set. A intersection A complement is an empty set. A union universal set is universal set. Don't get confused over these two symbols. It is a union, this one is an universal set. And sixth subdivision, A intersection universal set is set A. Then on cardinality, we have 3 properties. For any 2 finite sets of A and B, n of A union B that is equal to n of A plus n of B minus n of A intersection B. If A and B are disjoint finite sets, then n of A union B that is equal to n of A plus n of B. So, what do you mean by disjoint finite sets? Okay. I consider A that is equal to 1, 2. B that is equal to 4 and 7. I am going to find out A intersection B. A intersection B means common between A and B. Nothing common. Empty set. If empty sets mean we can say A and B are disjoint sets. Therefore, A and B are disjoint sets. Now, I am talking about overlapping sets. I consider A that is equal to 1, 2, B that is equal to 2, 4. Now we can find A intersection B. We have 2 is common, correct? If at least one element is common, we can say the two sets are overlapping sets. Therefore, A and B are overlapping sets. We know that n of A union B that is equal to formula. I only told n of A plus n of B minus n of A intersection B. If A and B are disjoint sets, then n of A intersection B, already told you if disjoint sets means nothing common between A and B. Definitely A intersection B is an empty set. How many elements in A intersection B? 0 only. Now only I give an example. Here A intersection B, it's A and B are disjoint sets. How many elements in A intersection B? Nothing. So cardinality of A intersection B is 0. Therefore, n of A union B becomes n of A plus n of B only. Okay. So if A and B are disjoint sets, n of A intersection B equals 0. At the same time, n of A union B equals n of A plus n of B only, because what about this portion? It becomes 0. Now, the last property. For any three sets A, B and C, n of A union B union C equals n of A plus n of B plus n of C minus n of A intersection B minus n of A intersection C minus n of B intersection C plus n of A intersection B intersection C. This property is for three sets A, B and C. Okay. So these are the properties to be learnt. I continue that exercise. I start that exercise 1.1 in the next video. Before I start taking that exercise 1.1, learn the concepts of sets and learn all the properties. Okay, I'll be teaching that exercise 1.1 in the next video. Thank you, children.